Hello everyone, I am Durga Sowjanya, Assistant Professor from ECE Department, MLR Institute of Technology. Today I am going to give the video lecture for the topic Interfacing of Sensors and Actuators for our subject Embedded System Design. So this is the topic we have discussed in our present video session. And here in previous session we have discussed what is sensor, what is an actuator, so what is an I/O subsystem, so what are the examples of these sensors and actuators, and in those examples we have discussed LED and push button switches. So how the LED will be interfaced to the microcontroller and push button switch will be interfaced to the microcontroller. So these are the topics we have discussed in the previous video session, and now in today's session we are going to discuss about IR sensor, PIR sensor, temperature sensor and stepper motor. So now the first one is IR sensor. So IR sensor module has a built-in IR transmitter and IR receiver that sends out IR energy and looks for reflected IR energy to detect the presence of any obstacle in front of the sensor module. So basically what is the purpose of IR sensor? IR sensor is nothing but infrared rays detected sensor. So here it can detect any object in front of the sensor through the infrared rays, and whenever the reflected signal will be going from the IR sensor, it will be taken as an input to the microprocessor. So here it consists of two parts, one is IR transmitter, another one is IR receiver. So the transmitter is used for sending the IR energy and the receiver is used for to receive the reflected IR energy to detect any presence of any obstacle. If any obstacle is in front of the sensor, immediately the sensor will send the reflected energy to the receiver. So that receiver is connected to the processor, which is used for detecting any presence of obstacle in front of the sensor. So it consists of IR LED and IR photodiode. So the IR LED can be used as IR transmitter, IR photodiode can be used as IR receiver. So these are combinedly called as photocoupler or optocoupler circuit. So here in IR sensor we have the two types of IR sensors are there. One is active IR sensor and passive IR sensor. So the basic operation which we have discussed previously, so it is known as active IR sensor. And we have another type which is passive IR sensor. This passive IR sensor is used to detect the motion in front of the sensor. Here it is used to detect any presence of the obstacle, and it can detect the motion present in front of the sensor. So the PIR sensor is nothing but passive infrared sensor, which is used for detecting the infrared heat radiations, and it is detect the presence of living objects that emit heat radiation. So in front of sensor, if there is any presence of living objects, that means any motion is detected in front of the sensor, then it can be used to detect by the PIR sensor. So it can be split into two slots. One is, and the two slots are connected to the differential amplifier. So whenever a stationary object is in front of the sensor, these two slots receives the same amount of radiation, and hence the output is 0. So when there is no moving object, we have a stationary object in front of the sensor. So then the two parts of that stationary object will be given the same amount of radiation in the inputs of PIR sensor, and hence here the PIR sensor is connected to the differential amplifier, so that here the difference between the two inputs will be 0, so that here it cannot detect any motion. So whenever any moving object is in front of the sensor, the one of the slots receives the more radiation than the other slot. Then we will get the difference between the two input slots, and hence the output will be swinged to either high position or low position, and hence it will be used for detecting the motion by the PIR sensor. So this change in output voltage results the detection of motion. In this way, the PIR sensor will detect the motion of the target. Here, this is the circuit used for interfacing the PIR sensor to our processor. Here, this is the PIR sensor and we have the LED. So, LED should be on whenever the PIR sensor detects the motion. So, here the LED will be on when the motion is detected by the PIR sensor. The output pin of the PIR sensor is connected to port 0. To get proper levels of 0 and 5, which is used to read the PIR sensor, the transistor is used. Here we are connecting the transistor to the PIR sensor to detect the 0 volts or 5 volts, which is the maximum value and minimum value. So if there is a motion, the difference between these two signals will be 5 volts, which indicates that the motion will be detected. If there is a stationary object, so it will be going to the 0 volts, which indicates the motion is not detected. So there is no motion to be detected by the PIR sensor. So the port 0 pin goes low indicates that the motion is detected and the LED will goes to on. And according to the mode of operation, if high should be enabled on the pin, which means that the motion is absent or period of trigger is over and will turn off the LED. So here when the pin is going to high condition, it indicates that there is no motion detected by the PIR sensor, or the period of trigger for this period of the PIR sensor will be over. And when this pin is low, it indicates that the PIR sensor will be going to on state, which is indicates that the motion will be detected and that LED will be glowing condition, that is on condition. Next one is temperature sensor. The LM35 series are used for temperature sensors. Here the output voltage is linearly proportional to the temperature. So whenever there is a difference in the temperature occurs, immediately this temperature sensor will detect the difference between the temperature and it converts that into the voltage. So here it already calibrated, hence it requires no external calibration. So internally we have the calibrated part for LM35. So it is already calibrated, there is no require for no external calibration. So it outputs 10 millivolts per each degree of Celsius temperature. So it produces, the LM35 sensor produces the voltage corresponding to the temperature. So we have to fix a voltage levels for each temperature. So depending on the detected temperature at that situation, the LM35 sensor will produce the voltage. So this voltage will be converted to digital by using the analog to digital converter. So here this microcontroller converts this digital value into temperature in the degrees to Celsius. This temperature is converted to ASCII form, which is suitable for displaying. So the ASCII values are fed to LCD, which displays the temperature on this screen. So this process is repeated after specified interval. So basically first the LM35 sensor, so which is detected the temperature and depends on the temperature, it can display the voltage levels. So these voltage levels are converted into digital by using ADC. So these digital values of the temperature are converted into ASCII form by the microcontroller, and so those will be displayed on the LCD. So this is the process that will be done in the temperature sensor, interfacing of temperature sensor. So now this is the circuit used for interfacing the temperature sensor. So the converting analog voltage produced by the sensor to digital data and is converted to temperature and is displayed on the LCD display. So here the A to D converter starts the conversion whenever a low to high pulse is to be on the WR pin, which is right pin of ADC 0804. So then we have to wait for end of conversion. So whenever the value is given to the ADC, so then this should be the WR pin, the right pin should be goes to the high pulse, and then we have to wait for end of conversion. Whenever the end of conversion signal will be received, so then the INTR becomes low, and hence whenever it is low, the read pin should be made low to copy the digital data which is in the ADC to the 8051 microcontroller. So after completion of one conversion, another cycle will be started. So this is the process of interfacing the temperature sensor to our microcontroller. So this is the stepper motor. Stepper motor is a brushless DC motor that divides the full rotation angle of 360 degrees into a number of equal steps. So as per the number of steps, the motor will be rotated in clockwise or anti-clockwise. So the motor is rotated by applying a certain sequence of control signals. The speed of rotation can be changed by changing the rate at which control signals are applied. So various stepper motors are available in our market with different step angles and torque rates. The microcontroller can be used to apply different control signals to the motor to rotate according to the need of the application. Here we need to write the program to rotate the motor in anti-clockwise or clockwise, or depending on the number of steps we have to use it in our application. So here we need to program the microcontroller as per our requirement in the application. So this is the interfacing of stepper motor. Here the 6-wise unipolar stepper motor can be interfaced with the 8051 microcontroller. Only 4 wires are to be used for controlling the stepper motor, and the 2 wires are used for connected to the plus 5 volts and ground pin. ULN 2003 driver can be used for driver for the stepper motor. Here this is the driver controller which is used for interfacing the stepper motor to the 8051 microcontroller. In the previous video session, we have discussed the IO subsystems which are used for interfacing the input and output devices to the microcontroller. Here in this interfacing of stepper motor in this application, this ULN 2003 which is the stepper motor driver. So it can be used as IO subsystem in this application. So the winding of the coil and the center tap measures the resistance between the leads, and from the center leads we will get half the resistance value of that winding. Depending on these values, we will get the number of steps per rotation. So we have to write our program to our microcontroller in these ports by using these ports to rotate the stepper motor to the number of steps depending on the number of steps and speed of the motor and the direction of the motor. So these are all will be controlled for our stepper motor in our program using 8051 programming. So this is the interfacing of stepper motor and temperature sensor as input and output devices to our microcontroller. So in present session, we have discussed what are the topics discussed in the previous video session, and what is IR sensor, what are the types of IR sensor, how can we interface the PIR sensor to our circuit, and what is temperature sensor, how can we interface the temperature sensor to our microcontroller, and what is the stepper motor operation, and how the stepper motor will be interfaced with our basic microcontroller 8051. So these are the topics which we have discussed in the present video session. Thank you.